Today's video is going over surface area, and if you thought arc length was anything close to disk and washer method, this is basically just shell method except one slightly varied step, which is the square root of 1 plus dy over dx squared, or it could be dx over dy squared as well, depending on which you're rotating about. Now the reason this is so similar to shell method is because we are revisiting the 2 pi as well as our radius, which here is x or y, depending on which axis you're rotating about. But this time we are multiplying with the arc length formula, which if you recall over here in my notes is the square root of 1 plus dy over dx squared or dx over dy squared, depending on what your function is. Now, if you ever get confused on which one is your radius for surface area, you don't have to draw the rectangles or anything to remember it. I just think, oh, I see the x-axis, I'm going to multiply it in terms of y. Or I see the y-axis, I'm going to multiply the terms of x. So basically just the opposite of each other. If you see rotate about the x-axis, use the y variable. If you see rotate about the y-axis, use your x. So let's get into some examples. So let's let our first equation be y equals x cubed, bounded by 0 less than or equal to x, less than or equal to 1. And let's rotate it about the x-axis. So let's write down what formula we would use. Of course, we put the 2 pi in front and then the integral from 0 to 1, which I got from this inequality right here. Since this is stating that x equals 0 and x equals 1, which are your bounds, and then y times the square root of 1 plus dy over dx squared dx. And so if you're wondering why I chose this equation in specific, remember what I said earlier, since we are rotating about the x-axis, what we're multiplying by in the front will be the opposite, which is y right here. And how I figured out that we're deriving y is through our original equation y equals x cubed. So of course we don't have all the information we need to plug in, because we do have our y, but we don't have our dy over dx, which is simply just a derivative of our y equals x squared. Because we do have our y, but we don't have our dy over dx, which is simply just a derivative of x cubed, which simply becomes 3x squared. So now we have all of the things we need to plug into this formula, which becomes 2 pi times the integral of x cubed, which I got from this equation because y equals x cubed, so I just substituted in, which also puts all of our terms in x, so it works perfectly, times 1 plus 3x squared dx. Now from here, we could just simplify the inside of the square root, which becomes 1 plus 9x to the fourth, which becomes a simple u substitution. And how I found that out is basically, if I derive this 9x to the fourth, I know that my outcome will have a 3 based on the derivative rules where this will subtract by 1. So it's 4 minus 1, which becomes 3. And I know that that's going to eventually cancel out this x cubed term. So let's let u equal 1 plus 9x to the fourth. Now our du becomes 36x cubed dx, and then our dx will equal du over 36x cubed. So plugging that in gets us the integral of x cubed times the square root of u, and then we'll substitute our dx for du over 36x cubed. We cancel out our x cubes, which simply gets us 2 pi times the integral of the square root of u times du over 36. Now we could just take out a 1 over 36, so let's say 1 over 18 pi, which all I did was simplify this 2 over 36, times the square root of u du. Now I apologize, I did save the bounds for last, which I should have not done. Let me backtrack a little bit. We are bounded from 0 to 1. And remember, when a u substitution occurs, we just plug in our bounds into our equation inside the u substitution, which will simply get us 1 to 10. So our bounds are from 1 to 10. Now our surface area simplifies to 1 over 18 pi times, oh sorry, I meant to put this pi in the numerator. So this is actually pi over 18, or 1 pi over 18, times 2/3 u to the 3/2, bounded from 1 to 10. Now we can remove this constant over here and multiply to the outside, so we end up simplifying to pi over 27 times 10 to the 3/2 minus 10 to the 1, multiplied by 10 to the 3/2 minus 1 to the 3/2, which if you want to simplify further, our surface area equals pi over 27, 10 times the square root of 10 minus 1. And our first example is finished. I would now like you to do the second one on your own. Now if you notice, we are rotating about the y-axis, and our bounds are x equals 0 as well as x equals 1. So our surface area is going to be 2 pi times the integral from 0 to 1 of x times the square root of 1 plus dx over dy squared dy. And the reason we are deriving x is because our function is an x equals function, so that is why. Now we don't have every detail yet again because we need to solve for the derivative of our x, which is fairly easy because our x equals e to the y, so our dx over dy equals e to the y. So now we have all of our details to plug in. So the integral from 0 to 1 of e to the y, because again we're just plugging in for that x since we know our x, times 1 plus e to the y squared, and then dy. Now this is one of those problems where all you have to do is set up the integral, so if you paused and tried to solve it, I apologize if it took you really long or if you just couldn't figure it out, but I may have forgotten to say set up the integral. So this would be a valid answer when just setting up the integral, but hopefully you get the idea of surface area, and thank you for watching.